Imagine a space that is completely empty. No stars, no planets, no dust, no light, just nothing. You might think this is truly nothingness, a cosmic void. But what if I told you that this emptiness is one of the most mysterious and powerful places in the universe? Welcome to the quantum vacuum, a realm that seems empty at first glance but is actually teeming with secrets that challenge everything we know about reality. You may have heard scientists talk about vacuum energy, virtual particles, or quantum fluctuations. But these aren't just theoretical concepts. They hint at a hidden structure of the cosmos that is both invisible and astonishingly active. Today, we're diving deep into the quantum vacuum mystery, exploring the strange, unseen world that lies beneath the fabric of everything we can touch, see, or measure. This is not science fiction, it's the frontier of modern physics. And it might just change the way you perceive reality itself. So what is a quantum vacuum? In classical terms, a vacuum is simply an empty space, a void without matter. But quantum mechanics refuses to let anything be that simple. In the quantum world, empty doesn't mean empty at all. The vacuum is a bubbling, restless sea of energy, where particles and antiparticles pop in and out of existence in the blink of an eye. These are known as virtual particles, ephemeral entities that exist for incredibly short moments and then annihilate each other, vanishing without a trace. It's almost as if the universe itself is playing a cosmic game of hide-and-seek, where the rules of reality are constantly being rewritten. Picture a calm ocean from a distance. It seems smooth, still, serene. But when you look closer, you see waves, currents, and hidden life moving beneath the surface. The quantum vacuum is that ocean, only it's made of pure energy and fundamental forces. Even in what we think is absolute emptiness, the universe is restless, buzzing with invisible activity. This quantum froth is not just a curious phenomenon. It has profound implications. One of the most striking consequences of vacuum energy is its role in the Casimir effect. Imagine two uncharged metal plates placed incredibly close together in empty space. Classical physics predicts no force between them. Yet when measured, the plates are mysteriously pushed together. Why? Because the quantum vacuum outside the plates teems with fluctuating energies, while the space between them restricts some of these fluctuations. This imbalance creates a subtle but real force, a silent push orchestrated by the vacuum itself. It's as if emptiness is conspiring to move matter, a whisper from the universe telling us that nothing is truly nothing. The Casimir effect has been observed in labs around the world, proving that the vacuum is far from inert. It may even hold clues to futuristic technologies, from frictionless nanoscale machines to propulsion systems that harness vacuum energy itself. Then there's the concept of zero-point energy, the lowest possible energy that a quantum system can have, even at absolute zero temperature. Classically, an object at absolute zero should have no motion, no energy. But quantum mechanics insists that the vacuum is never perfectly still. Particles jitter, fields fluctuate, and energy remains, no matter how hard we try to freeze it out. Some physicists believe this zero-point energy could be the source of dark energy, the mysterious force accelerating the expansion of our universe. If true, the vacuum is not just a passive background, it could be the engine driving cosmic evolution on the largest scales imaginable. Imagine that, the same invisible froth that exists in the tiniest empty patch of space might be pushing galaxies apart across billions of light years. And yet, the quantum vacuum remains deeply enigmatic. Experiments have shown phenomena that are almost paradoxical. Consider the Lamb shift, a subtle change in the energy levels of hydrogen atoms. This effect, first observed in the 1940s, can't be explained without invoking the vacuum's fluctuating energy. Even the humble hydrogen atom, the simplest building block of matter, is subtly sculpted by the restless activity of empty space. It's as if reality itself is shaped not just by particles and forces we can see, but by a hidden symphony of virtual particles dancing in the background. These particles appear and disappear so quickly that they evade direct detection, yet their influence is unmistakable. One of the most mind-bending aspects of the quantum vacuum is the idea that it might be the birthplace of the universe itself. Some cosmologists propose that the Big Bang could have arisen from a quantum fluctuation, a spontaneous bubbling in the vacuum, giving rise to all matter, energy, space, and time. This doesn't mean the universe popped out of nothing in the sense we usually understand nothing. The vacuum is not absolute emptiness. It's a seething quantum landscape with potential energy waiting to manifest as reality. In this framework, creation itself emerges from the hidden activity of the quantum vacuum, suggesting that emptiness is not empty at all, but fertile and generative, capable of spawning galaxies, stars, and planets. And if the vacuum can create universes, could it also influence them in subtler ways? That's the question behind quantum field theory, the framework that underpins modern physics. According to this theory, every particle is an excitation of an underlying field, and the vacuum is the baseline state of these fields. Even empty space has structure, tension, and dynamism. Phenomena like vacuum polarization, where the vacuum affects the distribution of charges and fields, show that space itself behaves like a medium, capable of bending and shifting the laws of physics. Imagine a trampoline with invisible threads pulling in different directions. Drop a ball on it, and it doesn't just sit there, it interacts with the hidden structure beneath, altering its motion. The quantum vacuum is that trampoline for the entire universe, shaping reality at every level. Perhaps the most startling frontier is the connection between the quantum vacuum and gravity. Physicists have long sought a theory of quantum gravity, unifying Einstein's general relativity with quantum mechanics. One tantalizing idea is that gravity might emerge from vacuum fluctuations themselves. In other words, the fabric of space-time could be a manifestation of the vacuum's energy. Black holes, cosmic expansion, and even the curvature of the universe might be intimately linked to the invisible activity of empty space. Some theorists suggest that if we could manipulate the vacuum, we might control gravity or even engineer new forms of energy. This remains speculative, but the implications are staggering. The vacuum could be the ultimate frontier, a hidden canvas on which the universe paints itself. Visualize this. If you could shrink down to the tiniest scales, far beyond atoms, beyond subatomic particles, beyond quarks and gluons, you would see a stormy, jittering landscape of virtual particles constantly forming and annihilating. Energies spike and vanish. Fields ripple like invisible ocean waves, and the very notion of emptiness becomes meaningless. It's a world that defies intuition, where the boundary between something and nothing is blurred. Some physicists even speculate that consciousness, at some fundamental level, might be linked to these quantum processes, though that remains highly controversial. The point is, the quantum vacuum challenges our deepest assumptions about what the universe is and how it works. And yet, despite all these discoveries, the vacuum holds secrets we might never fully grasp. We can measure its effects, observe its influence, and even harness some aspects in laboratory experiments. But the full nature of the quantum vacuum is elusive. It exists at the intersection of science and philosophy, reality and imagination. It's a reminder that the universe is stranger than our minds can easily comprehend, and that even the emptiest space is alive with mystery. There's also a practical twist. Understanding the quantum vacuum is not just an abstract pursuit. Technologies like quantum computing, superconductors, and even GPS systems rely on principles derived from quantum field theory and vacuum effects. Engineers manipulate vacuum states to control energy levels, particle behavior, and electromagnetic fields. In a sense, the vacuum is both a laboratory and a playground, a place where the rules of physics are tested, challenged, and sometimes rewritten. And if we step back and think cosmically, the vacuum might even hold keys to the ultimate fate of the universe. If dark energy is indeed a manifestation of vacuum energy, then the expansion of the cosmos is fundamentally linked to these invisible quantum fluctuations. The universe might expand forever, rip apart in a big rip, or undergo cycles of collapse and rebirth, all depending on the properties of this hidden energy. In that sense, the quantum vacuum is not just the background of reality. It's the scriptwriter, the stage, and the actor in the cosmic drama. So, what have we learned? The quantum vacuum is not empty. It is a restless, dynamic sea of energy that shapes atoms, guides forces, influences gravity, and may have even sparked the universe itself. Its influence stretches from the tiniest subatomic scales to the farthest reaches of intergalactic space. It is a paradox, a void that is full, a silence that speaks, a nothing that is everything. And perhaps most intriguingly, it reminds us that our intuitive notions of emptiness, space, and reality are profoundly limited. The universe is far stranger than it seems, and the quantum vacuum is the silent, invisible heart of that strangeness. As you ponder this, consider this final twist. What if everything you see, everything you touch, everything that exists, owes its existence to a restless, unseen sea of virtual particles dancing in the void? What if the emptiness between atoms, between stars, between galaxies is not a passive backdrop but the very foundation of reality? Every photon of light, Every gust of wind, every beat of your heart, is ultimately influenced by this invisible quantum froth. Reality, as we know it, emerges from a medium we cannot see, a medium that is alive with potential. And that, perhaps, is the greatest mystery of all. If this journey through the invisible heart of the universe has left you amazed, intrigued, or questioning everything you thought you knew, don't forget to let us know in the comments what you find most mind-blowing about the quantum vacuum. Hit that like button if you enjoyed traveling to the edge of reality with us. And make sure to subscribe to Cosmic Horizon Hub for more adventures into the mysteries of the cosmos. Every week, we uncover the hidden structures, forces, and phenomena that shape our universe in ways that are stranger than fiction. Join our cosmic community because out there, beyond what the eye can see, the universe is whispering secrets. And together, we'll listen.